Welcome to aminacademy.com. In electrical engineering, let us discuss the terms electric field, field intensity, electrostatic induction, electric flux, etc. First, we'll discuss about an electric field. We know that in the medium around a charge, a force acts on a positive or negative charge when they're placed in that medium. If the charge is sufficiently large, then it may create such a huge stress as to cause the electrical rupture of the medium, followed by the passage of an arc discharge. The region in which the stress exists or in which electric forces act is called an electric field. That means what? Around the electric stresses, the medium created, that is electric field medium. The stress is represented by imaginary lines of forces. The direction of the lines of force at any point is the direction along which unit positive charge placed at that point would move is if free to do so. It was suggested by Faraday that the electric field should be imagined to be divided into tubes of forces containing a fixed number of lines of force. An electric field is defined mathematically as a vector field that can be associated with each point in space. The force per unit charge exerted on a positive test charge at rest at that point. The formula of the electric field is given as E equal F over Q, where E is the electric field and F is electric charge, that is Q is the charge of electric charge, Q is the charge, F is the force. Now, next definition, electrostatic induction. It is found that when an uncharged body is brought near to a charged body, it acquires some charge because of some charges flows from charged body to uncharged body. This phenomenon of an uncharged body getting charged merely by the nearness of a charged body is called an induction. An electrostatic induction, further definition, is the process in which the redistribution of charge takes place within a body when an electrically charged body is brought near to it. Here, two charges brought near to it, some charges passed, that is negative charge passed to the second body also. If you come to another positively charged nearby to the negative charge, what will happen? So, this first body become negative charge, the second body become a positive charge. That is what due to electrostatic induction. Next, electric flux. Electric flux means or Faraday tubes. Consider a small closed curve in an electric field. If we draw lines of a force through each point of this closed curve, then we get a tubes as tubes. The lines act as a tubes. It is called tube of electric flux. It may be defined as the region of space enclosed within the tubular surface formed by drawing lines of force through every point of a small closed curve in the electric field. Since the lines of force end on conductors, the two ends of a flux tubes will consist of a small areas. For example, ds1 and ds2 on the conductor surface. If surface charge densities over these areas are sigma 1 and sigma 2, then the charge of the two ends of the flux tube will be sigma into ds1, sigma 1 into ds1 and minus sigma 2 ds2 like. These charges are assumed to be always equal but in opposite to each other. Now, What is electric flux? The definition: the property of an electric field that may be brought off as the number of electric lines of a force on electric field lines that intersect a given area. That means the particular area, how many electric lines are crossing, is called electric flux. The electric field lines are considered to originate on positive electric charge and to terminate on negative electric charges. The flux line is always imagined to start from positive charge to the negative charge. Now, next, electric field strength. Field strength, electric intensity at any point within electric field may be defined as in either of the following three ways. It is given by the force experienced by a unit positive charge placed at that point. Its direction is the direction along which the forces act. That means here electric field is a quantitative expression of the intensity of an electric field at a particular location. The standard unit is the volt per meter. Volt per meter is a unit of electric field strength. A field strength of 1 volt per meter represents a potential difference of 1 volt between points separated by 1 meter. Electric field strength is also referred to as electric field intensity. Now, therefore, we can write E equal F over Q. That is Newton per Coulomb. Newton per Coulomb. Now, F is further expressed Q into 1 over 4 pi, is 4 pi epsilon 0 relative epsilon r d square. That which is equal 9 into 10 power 9 Q over epsilon r d square. Now, regarding this electric field strength, we will discuss about Van de Graaff generator. Look at this figure. This is a Van de Graaff generator. A Van de Graaff generator is an electrostatic generator. That means it produces charges which uses a moving belt to accumulate electric charge on a hollow metal globe on the top of an insulated column, creating very high electric potentials. Look at here. This a belt is move around inside that big spherical vessel. So its charges are while it's moving, the charges are accumulated around the sphere. It's an electrostatic generator which uses a moving belt to accumulate electric charge on the hollow metal globe on the top of an insulated column, creating very high electric potential. It produces very high voltage direct current, that is DC voltages. DC electricity at low current levels. It was invented by American physicist Robert J. Van de Graaff in 1929. The potential difference achieved by modern Van de Graaff generators can be as much as 5 megavolts. A tabletop version can produce on the order of 100 kilovolt and can store enough energy to produce visible electric sparks. Small Van de Graaff machines are produced for entertainment and for physics education to teach electrostatics. Large ones are displayed in some science museums. Suppose while charged Van de Graaff generator, if you touch the body of that one, your hairs will go straighten and go upward. We can feel that charge is produced in the Van de Graaff generator, and that charge go to your body, so your hairs are go upright. It's very interesting, and which are placed in different science museums. For further details, we can explain this. Let's consider a large spherical shell of radius r. If we place a charge of magnitude q on such a sphere, the charge will spread uniformly over the surface of the sphere, and the electric field inside the sphere will be equal to 0, and outside the sphere will be due to the charge q placed at the center of the sphere. So the potential outside is that of the point charge, and inside it is constant, namely the value at the radius r we thus have. The potential inside conducting spherical shell of radius r carrying charge q, that is equal to constant, and is given by some formulas. That is E equal q over 4 pi epsilon 0 d square. Now, so far we discussed some terms about electric field, electric intensity, electrostatic induction, electric flux, and Van de Graaff generators. We have done. Please subscribe our YouTube channel.